Working. Okay, thank you very much, Julio, and all of the presenters. This is a very interesting moment, collaborating and sharing information. So I am Edgar. I am the researcher in the Edmond and Elise Safra International Neuroscience Institute in Macaíba. So I will present our facility and some opportunities that we can share expertise and equipment. So the idea is space suites are used to protect a human being in the extreme environment of space, but we are using the space suites to train in the Earth's gravity. So it's a little bit different. And if we understand how hard it is to use it and train in the Earth, probably we can prevent like technical problems or even health problems in the space. It's very known that it's very hard, it's complex to use like this. It's very hard to wear a spacesuit. It's not new, but we're still using the same methodology, like in this video. It's very complex. It's physically demanding for the user. And the question is how we can improve this method. It is even worse in this case when the spacesuit is very heavy. This one weighs like 150 kilograms. So it's impossible to wear it alone. You need a team. And the idea is how we can use our facility here in Macaíba to improve or train the method to prevent or anticipate technical problems or even health issues. So it's complex to wear it, to get in the spacesuit, and also to get out of the spacesuit. But there is no way. We have to improve the spacesuit and also the method or the equipment to support the system, like this one. To get out is very hard. So we can record like body movements, biopotential, and use this information to prevent or even to follow what's happening, what's stressful for the user. And this is worse when you use a very heavy spacesuit in the Earth's gravity. So you can see here, it's very hard to control your balance. And when you are training in the Earth's gravity, you are like controlling, you are changing your motor control, your vestibular system to use the spacesuit in this case, even to execute a very simple tasks like this. And here in our lab, we can use like a 0G system. It's a body weight support to simulate this kind of training. So understanding what's very stressful for the user in a spacesuit, in a heavy space, especially in a heavy spacesuit, we can understand health problems like this. So pre-flight, in-flight, and post-flight. It's in this review you have several questions about how to use and the problems that they already know. So the neck, shoulder, and the lower limbs, and how we can use technology here in the Earth's gravity to anticipate and prevent technical problems. So this is the idea or the aim of our presentation. Here is the SPACESUIT with a human being, and the idea is to use this kind of wearable sensors in the healthcare centers, especially outside of Brazil. It's a very good field of research. It's increasing exponentially. So you can use for insole, for smartwatch, or even for clothes. And the idea is if you integrate in the SPACESUIT, you can follow what's happening. As you saw in the review paper, the user shows a lot of health problems, and if we can track this data, especially online, you can make new kind of modifications in your SPACESUIT, and you can prepare physically, not only physically but mentally, the users. So here, this is our institute. This is the Edmond Lili Safra facility here in Macaíba, in the northeast of Brazil. You guys are welcome to visit our facility. So I'm presenting only the neurorehabilitation lab that we are using to develop projects for the SPACESUIT, wearing, and mobility evaluation. So this is an example. We can use and develop systems with immersive virtual reality, and if you want, you can combine with electroencephalography. We usually record in our patients electroencephalography to understand motor control or motor disorders in your nervous system. And also we can track the body movements with passive and active markers or inertial sensors. And here, this is our zero-G system, the body weight support that we can use with a SPACESUIT. So in this case, we can test like standing, walking, doing reaching movements, doing tests that usually the user will do in a very hard environment. So this is the system, and we can combine the zero-G support, this body weight support, with virtual reality, electroencephalography if you want, and electromyography to understand how hard it is to execute movements with your SPACESUIT. So we can follow a fatigue, for example, to understand when you have or when you will develop problems in your neck, your shoulder, or mainly in your back, since you are in the Earth's gravity. This is an example that we already developed, but for the spinal cord injured patients, we use this system with EEG, electroencephalography, virtual reality, standing, body weight support, and treadmill. So the idea is to combine for rehabilitation, but more than rehabilitation, we can use to train the user of a SPACESUIT and track the data. So this is this project, and this data were published in 2016. And the idea is if you can track with a SPACESUIT all the same data in a virtual environment, or even with a real SPACESUIT with electromyography, inertial sensors, we can make a pattern of these movements and anticipate problems, mainly health problems of the user. So we can probably contribute to develop this SPACESUIT. This is an example that we use this body weight support. In this case, an exoskeleton for spinal cord injured patients. But it's the same. We can use all these wearable sensors to track in a SPACESUIT because these sensors are wireless. And the idea is to develop and use this facility to develop and contribute to new SPACESUITs. As an example, we have these other projects of our students. In this case, Junior is developing inertial sensors to detect the position of the links, and this inertial sensors stimulates the muscles, so we can track exactly, and also we can use the electrostimulation to stimulate your muscle, or even to give a feedback for a user in a SPACESUIT. In this case, we use for neurorehabilitation, but we can use as a feedback for the user in a SPACESUIT, so that he or she can use a SPACESUIT in a health way to prevent like back pain, neck, or shoulder problems. This is a continual improvement. In this case, we are testing some controllers, and these controllers should be real time, so that we can detect movements or acceleration and give a feedback for the patient, or even change some aspects of the SPACESUIT. We can integrate. And as the user of a SPACESUIT in the Earth, gravity is different from the space. We can also use this kind of sensors in solids, so that we can track like the balance or the pressure, so that we can train better how the user will use the body in a SPACESUIT to prevent back pain, for example, as we saw in that video at the beginning. The user was doing very simple task to grab something, reach something in the ground, but he or she had to make a very strength movements to do simple, very, very simple tasks. And the idea is to use this kind of sensors also for rehabilitation, or even for feedback, to give a feedback for the user in a SPACESUIT. In this example, we are using these sensors also in the virtual environment. So we can train in any kind of virtual environment. It's very easy to program or code the task. Here, this is our other project for the upper limbs, for the arms. In this case, as one of the problems or the challenge for the SPACESUIT are the gloves. In this case, we can think about using this kind of very easy to use technology, using a 3D printed support and bowden cables. We can use this kind of method to help the user in a SPACESUIT. And this is the other very, very simple, easy to use based on Arduino. We can track the EMG with wireless and wearable sensors, so that we can track in a SPACESUIT and develop new ways of body data recording. This is my contact, and this is the building that we have this new rehabilitation lab, and all of you are invited to visit us and use this facility if we can help development of the SPACESUIT projects. Thank you.